This is how everything began. One unimaginable moment gave birth to all of this, galaxies swirling in silent harmony, stars lighting up the darkness, and the building blocks of everything we know set into motion. But before it all, there was nothing. Then, the bang. 13.8 billion years ago, there was no light, no space, no time. Then, in an instant, the universe was born. From a single, searing flash, space itself expanded. Energy surged. Matter began to form. The cosmos had awakened. In the first fraction of a second, the universe expanded faster than the speed of light. A violent surge of pure energy filled the void, searing hot, immeasurably dense. As space cooled, that energy began to take shape. Subatomic particles, quarks, and gluons danced in a chaotic storm. Some joined forces to form protons and neutrons, the building blocks of atoms. In just 3 minutes, the universe entered a new chapter, a moment known as Bang Nucleosynthesis. Within the first 3 to 20 minutes after the Big Bang, the searing energy cooled just enough for the first atomic nuclei to form. The lightest elements were born: hydrogen, helium, and trace amounts of lithium, the simple ingredients of everything to come. No stars, no galaxies, not yet, but the universe had a recipe, and it was just getting started. For hundreds of thousands of years after the Big Bang, the universe remained a hot, dense fog, light trapped, unable to travel far. But around 380,000 years later, everything changed. Electrons finally slowed down enough to bond with protons and form neutral atoms. This moment, called recombination, made the universe transparent. For the first time, light was free to move through space. That ancient light is still traveling, and we can still detect it today. We call it the cosmic microwave background, the oldest light in the universe. This is the actual map of the cosmic microwave background, ancient light released 380,000 years after the Big Bang. Captured by the Planck satellite, it shows tiny ripples, the seeds of galaxies, not just an image, a baby picture of the universe. A few 100 million years after the Big Bang, gravity pulled hydrogen and helium into colossal clouds, tens of light years wide. These clouds collapsed, igniting the first stars, many hundreds of times more massive than our Sun. They lived for only a few million years before dying in cataclysmic supernovae. These explosions forged heavier elements like carbon and iron, seeding the universe with the raw materials for planets and life. Some of the most massive stars collapsed into black holes, warping space and swallowing light. Over hundreds of millions of years, gravity continued its silent work, drawing clusters of stars into vast cosmic cities we call galaxies. Some spiraled into elegant disks, others collided and merged into chaotic, glowing giants. These galaxies stretched over 100,000 light-years across, containing billions, sometimes trillions, of stars. The earliest galaxies flickered to life when the universe was just a few 100 million years old, piercing the cosmic darkness with their light. From these humble beginnings came the grand structures of the cosmos, galactic webs stretching across the universe. Over billions of years, galaxies didn't just form. They gathered into massive clusters, woven into the vast cosmic web. Invisible threads of dark matter helped sculpt this structure, guiding the dance of galaxies through space. And deep at the heart of many galaxies, including our own Milky Way, lie supermassive black holes, millions, even billions of times more massive than our Sun. The universe today spans 93 billion light-years, and it's still expanding, still evolving. Stars are born, stars die, galaxies collide, black holes grow, and we, made of the same elements forged in those early stars, are just beginning to understand it all.